Okay, hi everyone. So I'm Anirudh Chiller. I'll be your trainer today. So I have more than 11 years of experience working with different technologies, different vendors. I worked in planning, architect, and different layers of networking. So let's start. We'll be discussing today about access list. If you must seeing my screen. So what is access list basically? So access list is something, let's say if you worked in the networking, so you know that network have a specific path to move the routes. Like from source to the destination, they have some certain path. Like they will be coming going by source. Let's say, let's take example here. Let's say this is the source, this is the destination. So there can be n number of devices in between, and they can be connect in any way. Okay, so as per your routing, the best path could be this. It can be this, depend on the routing. So how the access list coming to the picture in this? So it will be working in a way, let's say this is the normal path that is going, and everything is going by this path. From source to destination, everything is allowed. But if you're working in a company or organization, so nothing, not all the things are allowed. So for that specific thing, we want that, okay, a specific department, let's say in a company, we have a network department, then we have HR department, or any different kind of department. So we are thinking that, okay, this specific team or department can have a specific access to the devices, or you can say they can access only three, four things. They can't access more than that. So for to make that happen, we have to use the ACL. And if you're seeing this diagram lower, this is the same thing. Like we are consuming here, like there are three pieces, PC 1, 2, and 3, and we have a scenario that let's suppose I'll be giving you a depth about the access list in the later slides, but here what is saying, let's suppose we want that this PC1 they can't use any video, they can't access H2 devices, means this PC1 can't reach anything which is connected to this switch. So of course there's a PC2, so PC1 can't reach PC2. So we don't want that. So to make this happen on this specific point, if you are seeing it, we can put access list that will be blocking that we can't go on a certain site or a certain destination. Same here, we want that it won't whoever is connected to S3 or lower to router R3, they can't use any update, they can't use file transfer protocol, they can't go to the web. So we can directly put access list here and mention the specific subnet. Okay, let's say take them as a three subnet. So we want that, okay, these three subnets are blocked, rest will be allowed automatically. So we'll be creating one access list or three access list having these three subnets, and or you can create a standard or extended access list according to your requirement. After that, we'll be permitting rest of the stuff. And same here, HR that we talked about, like they want to use everything, so we can open everything here, like everything is allowed, or they want to use specific things, we can put access list here because the department is here. And same, this is the internet and this is the edge router. So all the company data from here and from here, they'll be landing on the edge router. So we want that they are able to access their emails. Let's say they can open the Gmail, they can use the Gmail, but they can't telnet anything which is in the open network. So we'll be blocking the telnet here and allowing the emails here. So that's the basic stuff of the access list. Let's move to the third part. How access list work in a packet level. So if you are a network engineer, you are well aware about the three-way handshake. So what is basically three-way handshake? It's a handshake between source to destination to make them concrete that communication happen, the first packet go and how the first packet actually go, or the rest of the packet how go. So how the communication happen in a three-way handshake, and why we call that a three-way handshake is that when the source want to reach to the destination, source will be sending a SYN packet to the destination. And once destination receive this, destination will be sending a acknowledgement for that SYN packet that source sent, and destination will be sending its own SYN packet to the source. Then source will be receiving, okay, I got the acknowledgement, but I got the SYN packet from the destination. So source will be sending again a SYN packet. So one, two, and three packets will be sent. So that's why we call it a three-way handshake. So in the same way here, what will be happening in case of ACL? Let's say this is the source. Let's consume this is the destination. So source will be sending one TCP packet. Let's say, okay, we want to talk. Then the destination will be sending one acknowledgement of this first packet. This acknowledgement is for the first packet, and they will be destination will be sending a TCP SYN, the same SYN that here sent by the source. So destination will be sending the same packet to the source. Okay, sure, let's talk. Then source will be sending a TCP acknowledgement, the TCP SYN packet acknowledgement. They will be sending, okay, let's have a connection. They will be having a connection. Then actual data will be sent here. In the same way, the actual data acknowledgement will be sent, and the acknowledgement is there, and whatever data is requested in this packet, that will be transferred by this packet, this specific packet. Data requested, acknowledgement sent, then data is transferred. In the same way, when the transfer happen, source will be sending a SYNAC, okay, I received the data. Okay, then destination will be sending, okay, I am finished and have no more data to send, like all data has been sent to you. They'll be sending a TCP fin, like finish. If you heard about the fin flag, this is a finish flag. That's a kind of last packet, you can say that. So source will be acknowledging that one, egg packet will be sent, and a TCP fin will be sent. Why the TCP fin will be sent? Because whatever source is requested, source has get that. So source will be sending a TCP fin. Okay, I have finished whatever my requirements are, whatever I want to reach. So I got that. So this is my final packet. So once that final packet received, the destination will be sending only the TCP acknowledgement. So that's how the communication will be happen in case of ACL. And it's more than a three-way handshake, but it's a kind of three-way handshake. You can say that because SYN ACK, then acknowledgement, then SYN ACK again. First the SYN is sent, then acknowledgement is sent, then SYN ACK is sent. So it's a three-way handshake, but it's an additional detail. So you can say additional uh, things will be added when your actual data is sent. So that's just the example. Let's move to the purpose of ACL. As we already discussed that why we use the ACL. ACL is something can be used for a specific traffic because if you're working in a live network or if you're operating your network engineer working in a live environment, so not everything is allowed within the company. So there are specific restriction that company servers can be used with specific subnets or specific teams. Let's say if you're a network engineer, you have access of all the devices. But let's say if a new joiner is coming and he has uh, come want to use the data center devices, everything, but you don't want to give him the access. You don't want that all the access to be in their hand. So in that condition, you have a specific that's a different scenario, but I just want to give you example. So you want to restrict a specific subnet to use to have a specific privileges. So a specific department, if you talk about in a general way, let's say uh, if a CTO, like the CEO type of persons who's kind of a high level, or you can say lead management kind of stuff. So they got these guys don't have any technical stuff, so they want to use whatever they want to. So you will be creating a specific subnet for them, and they might have a specific access to outside internet that they can use everything because they are the leadership and the management guy, senior management guy. So it happened like in a startup company, or you can say the senior management I'm talking about, like the founder kind of thing. So how we use the ACL. ACL can be used basically in two ways, inbound ACL and outbound. Inbound is something that we use to restrict the incoming traffic. Let's say this is a router, and let's say this is the internet, I for the internet. Okay, so we are having two ports. Let's assume it's 1 by 0. Let's assume it's 2 by 0. Okay, so how it will working? Let's suppose there is a like you can say load of network is come on. Let's say it's a LAN. Okay, let's say something is coming from the LAN. So we want that okay any specific kind of traffic would be reaching to the R1. So if we are applying a ACL here and for the incoming traffic from the LAN, so that ACL will be called in general as an inbound ACL. because it's restricting the specific traffic or allowing the specific traffic on an incoming port, on a port, and receiving the traffic on that port. So that's why we call it the inbound ACL. And if we say let's R1 is sending something to the outside to the internet and we restrict something, okay, only this specific subnet or IP can travel to the internet. So, and we are sending this to the out. So that's why we call this a outbound ACL. Let's move to the next slide. Okay, type of ACLs like in IPv4. Why is mentioned IPv4? Because majorly we use the IPv4 in the current environment or current life scenarios. If you're working in an organization right now in these days, IPv6 is coming to the picture before all the IPv4 IPs are consuming. So it will be coming, but majorly we still use the IPv4 as a major thing. So let's talk about the IPv4 only. I'll be talking about IPv6 later in the later templates as well. Let's talk about what's type of ACLs. ACLs are two types, standard ACL, extended ACL. So what is standard, what is extended? So standard ACL is something you use nearby source only. Why the source? Okay, let's say it's R1, R2, R3. Okay, so you want to do that, okay. Is a syntax like how you were creating a standard access list. So is a syntax access list, then the number it should be 1 to 100. So you can put any number. If you want to permit anything, you can deny anything, depend on the you. So from which source you want to permit or deny. Let's suppose on this specific point, let's say it's a 1 by 0 interface. So on this specific interface, you want to permit or deny something specific. So you will be putting the this access list here. Okay, on this specific point, whatever is coming from this IP or this subnet, I have to allow everything. So let's suppose R1 will be getting something, a lot of route, let's say 1000 route. And but on this specific point of the R2, we put access list, okay, whatever is coming with the source of 192.168.30.0. The fourth octet can be anything. It's a wildcard. We'll be talking about the wildcard later as well. So whatever is coming with the first three octet 192.168.30, the fourth can be anything. So I'll be allowing that one only and rest can be denied. So I'll be putting this access list here. Only that specific subnet will be allowed. So that's how the standard ACL will work. But of course, it depend or it can be put nearby source only. So how the extended coming to the picture here. So extended will be used and have a priority over, you can say not the priority, like it can be used instead of standard because in live environment when you're working you don't need to just block any specific subnet, you need to block a specific port, specific IPs which is going to a specific source destination. So why how we can use the standard ACL and why it is prioritized over the sorry why we use the extended ACL and it's prioritized over the standard one. So because we can put it inside like nearby source or destination as per your requirement, we can like use it as per the source or destination TCP or UDP ports. Like they can be a number of ports. You can mention any of the ports. Like there are some standard port, but you can use any other ports with the TCP or UDP, depend on your company requirements or scenarios. Doesn't matter. And it also can be used with the protocol. So you can block any specific source or allow any specific source or destination. You can block any specific protocol again or allow anyone, or you can block or allow any specific service like let's say TCP or UDP port service. So depend on the you. So here is the example that is same, the syntax is same, just starting from the same like access list. Then you can put anything number like from 100 you can start it. Let's say we taken a 103 and we want to permit specific thing. Okay, let's I will be taking this example again on interface 1 by 0. So what you want? We want to allow a specific TCP service only for which for this specific subnet. So R1 if something coming from R1 1 to 92.168.30.0, first three octet will be checked. 1, 2, and 3. Fourth can be anything. It can be anything. This is the wildcard we'll be talking later. all kind of service allowed, and this is the port. If they are coming from port 80, they'll be allowed. If they are coming from, let's say, port 84, they won't be allowed. And rest will be blocked if you are putting a specific access list. Again, let's say you are allowing this one and rest you are denying that, so only this traffic will be allowed. Depend what kind of scenario you are putting. Let's move to the fourth style. Okay, what is wildcard? How wildcard will be helping? If you remember, we use in previous example access list in both extended and standard. Let's say 10 permit 192.168.30.000.255. So this is the standard access list and extended in both way. We use the same wildcard here. So what is that exactly? So if a zero is mentioned here in the wildcard, like the zero is mentioned, so that means we have to match whatever correspondence to that specific IP. Like if we let me put the wildcard here, 0000255. Okay, so if zero is mentioned, so this should be matched. If zero is mentioned, the second should be matched. If zero is mentioned, third should be matched. There is no zero, so fourth octet can vary. And why it is mentioned that the one ignore the corresponding bit value in the address. Why it's mentioned as 10255? Because they have divided that in terms of binary number like this. Let's talk on a next slide for the same thing. Okay, it's not there. Let's me 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 1, 1, 1, 1, 1, 1, 1. Okay, so this is the same wildcard 0.0.0.255. So when we divide that in the binary, so that's how it will be coming up. So 0 means match everything. First one 192, match it. Second one 168, match it. Third one is 30, all 0, match it. Fourth one is 0 and there are ones, so you don't need to match it. It can be anything from 0 to 255. Of course, we have to remove network and broadcast bit. Yeah. So yeah, here's just example. Let's say you want to it's for a range specifically. Earlier we have done for the specific IP, if you want to block a range 172.16.00 to 172.31.2555. So the starting IP is this and wildcard this be 0.15.255.255. You can solve it by yourself. Let's talk it here. So if we talk about 170, because the IP is starting from 172.16.00, so we'll be talking here. Give me a second. Let me show you how it's work. Okay, sorry for the delay. Again, okay, we'll be talking 172.16. This is the starting IP, and this was the wildcard. And we divide that in terms of a binary number. So, how 172 will be written in when we are talking about the binary? This is 172, 10101100. This is 16. This is 0. This is 0. And if you're talking about the wildcard, how it will be written? This is 0, all zeros. This is 15, 255, 255. So basically, it's like how you can define the range. Like if you know about how to convert a specific IP or any subnet mask or any wildcard into binary number, so it would be easy for you. So it's basically what it is saying what we have to keep. So if you remember in the previous two slides, like we said that 0 means match everything, 1 means we can ignore that. So there are everything, all 8 in the first octet are 0. So we have to match everything. This is the IP part. Red one is the wildcard part. So we have to match everything in the first octet because all zeros are there. Then in the second octet where 16 is mentioned, only first four are 0, next four are 1. So you have to match first four, means 0, 0, 0, 1. Rest can vary. In the rest two, there are all 1, so they can vary. It's just a maximum and minimum value for any specific IP, like what could be the minimum IP, let's say 172.16.00. So this is the minimum IP, 172.16.0.0, and I think if I'm not wrong, this is the maximum IP. I think so. This is just the maximum minimum IP, nothing else. Let's move to the second slide. So it's a question for you. What IP address does this combination isolate? Okay, let's suppose you put something here with the wildcard mask here. So what kind of IP address this combination is going to isolate? Think about that. Okay, let's talk it here. Is it the same one? Yeah, it is the same one. So this is the IP, this is the wildcard. Again, we divide that. First part is same, IP 172.168.20.37, just divide into the binary, and this is 0.0.0.254. Red one is the wildcard, black one here is the IP. So this one is saying what exactly we have to keep. So we have all the zeros here, so that means we have to keep the first octet. What was that? 192. Okay, all zeros in the second octet, so we have to keep the IP of the second octet as well. All zero in third octet, so again 20. Then in the last octet, it's 254. So we can't use the first 7 bits, and we can use the like last one is 1. Like we have to use the last one as 1. So that's how it will be working in the wildcard. Like you can have a separate example. Let's say, let me give you a question kind of thing. So you 92, 168, 20, again 37, just changing the mask, 224, 255. So you have to find out which IP it will isolate. Thank you. Just move to the next slide. Okay, that's the same thing we just called. And in the previous slide, what kind of IP it will isolate everything in the first 3 octet and last can vary that we discussed yet. Okay, why wildcard will be saying like that? It's the same info that we discussed. Like the 0 means must match, 1 means ignore. Let's say 0, 0, 255, 255. So first 2 octet must match, last 2 octet they can vary. That's how you can do that. Okay, let's move with the example. Let's suppose somebody telling you this is the access list, and it's a standard one because if you see access list one, if more than 100, then it's extended and you have certain advantage of extended list over the standard one. So in the first example, let's say you are permitting a 0000. It's a kind of default route, and what you are writing here 255, 255, 255, 255. So in the first line I'm talking here, so basically what you are saying, this is the IP address and this is the subnet mask. So if you convert them into the bits, everything is in the bits. It will be like that: 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. Okay, so it's 255, 255, 255, and 255. So what's this first line basically saying that? Okay, we have mentioned one IP address, although it's a default one, but we mentioned that. Let's take it as a IP first, so it would be easy to understand. So let's take the wildcard. So what if you remember, 0 match, 1 can vary. Okay, so is it a 0? No. So the first octet can vary. So instead of 0, it can be from 0 to 255, anything. Second octet, 255 again is 111, same as the third, same as the fourth. So all 4 octet can be any value from 0 to like 255. So it can be 111, it can be 192, 168, 32, 37. It can be any IP. It's kind of default route they are allowing. So instead of writing this one, we can write the access list like this. Access list permit what you want to permit, any, or whatever is coming, we want to allow everything. And the first one is saying the same thing, the second one is saying the same thing. But there's a two scenarios you can use. Like if you want to use one, that's okay. If you want to use second, that's fine as well. Depend totally on you. Let's say in the second example, in the second example, let me erase this one. So we'll be having a bit space. In the second example, what we'll be saying here, access list is a standard one, access list one. We want to permit this specific IP and 000. Wow. Why 00? S- s- So if wildcard is 00, so that means 000. If we convert that into the binary, all zeros should be there. And if you remember, 0 means we have to match everything. So all 0 in the first, so we have to match 192 in the first octet, all 0 in second, 168, all 0 in third and fourth, so 10.10. So that means we have to allow only one specific. If something is coming with one specific IP or this specific route is allowed, if you are putting this access list, rest can be denied if you have a deny statement as well. So instead of putting this, we can use the access list like this. Access list one permit when you type the host. So that means you are allowing a specific IP. You mention, okay, this is the host. If you're using the first access list or second, that's the same meaning. You can use any one of them, they will work in the same manner. Let's move to the second slide. Next slide. Okay, there are something or some scenarios that we already discussed where we can put the standard list and where we can put the extended list. Standard when we talk about the standard list, we want to put that as close to the source and not to the destination. And we are talking about the extended ACL. We try to put them to the source that traffic that like it's a general way you can put when we're talking about let's say R1, R2, and R3. So you can put the access list here or you can put the standard access list here. It will work in both way. It's coming from something is coming from R1, so you can mention okay if something is coming from R1, we have to block or allow something, or we can say we are sending something to the R2, so we can block and deny something. So it will work in both way. And same with the extended list. If you want, that's up to you again. You want to try to put it close to the source only. Okay, let's say this is the source and you want to put it here, so it would be like in a general way, it is advised to use that here instead of putting here and blocking the specific traffic coming from the R2, so you can use it on the R1 directly. Just a suggestion, depend on the again on the configuration, what kind of environment or design you're using. Okay, so here again, let's say this is the PC1, PC2 specific IPs of their PCs already defined here, and let's say on R1, this is the R1 router, this is the R1 router, this one. So what they are saying, we have created one access list that will be allowing a specific IP with a wildcard. If you're seeing 000 in 3 octet of the wildcard, and fourth one can vary. So it could be 192, 168, 10 dot something. It can be anything 0 to 255. What you do, then you use a second ACL in the same way, and you can put a deny statement. So what it will do? Let's move here. The rule one. Rule 2, Rule 3, Rule 4. Why this is mentioned? This slide and previous slide is matched. So this slide is saying that when you put this access list on, let's say you put it here on this specific interface, when you put that, it will be only allowing the specific traffic here coming from 192.168.10.0 to 255. It can be anything. But if you're using this other statement as well, so there is a contradiction. The ACL won't work. Why? Because if you put both two statement in the single ACL, so why it is a contradiction? In the first one, you are allowing something with the IP 192.168.10.0 or 10.255. They can be any IP till 0 to 255 in the last octet. Then you are giving a statement access list to deny any. Like whatever is coming, we are going to deny. So it's a contradiction. First one is allowing, second one is denying. So we can't use that. This is the basic rule that you can't deny something that you already permitted. We are permitting this thing, then we are denying everything. So it can't be work. Or you can't permit something that you already denied. Why it is saying that? Let's suppose if you're using the second statement here in the first, so the second won't work because we already denying something, you can't permit that again. Third one, if nothing is permitting, nothing will pass. Of course, if you're using access list, you have to either permit something, so else it won't work. You can't say that, okay, I'm not permitting something and it should go. So you have to do something. And the best ACL in the world does nothing if it's not applied. Just a joking scenario, so leave it. Let's move to the standard ACL. It's just a statement is giving. Let me maximize the size here. That's a bit. Okay. So how ACL will be used? If you remember here on R1 on this specific port, let's say we create not on the port, we will be creating the access list in the global only. Let's create access list and denying the host 192.168.10.10. It's a specific host. What is this host? It's a PC1. If you seeing this is the IP. On this specific here, we are denying this, and after that we are permitting any. And when we go to the interface 000, we are calling that inside a access group. This is a statement how we can make that work it. So let's say how it is gonna work. Okay, sorry for the interruption, guys. So what we are saying here that PC1 won't be able to access anything here. Like if there is any other PC connected here and having the IP, let's say 192.168.10.11/24. So that will be using whatever, or let's say you want to reach here, like let's say it's a PC3, he can reach to the PC2, but PC1 can't be reaching to the PC2 because we are putting access list here to block that specific IP or specific PC. So here is some naming convention, like how we can use the, if you know, we use like this access list, then list number, let's say 10, and in case of extended, let's say 110. So we can use the naming convention as well. So alphanumeric character, how you can use that. This is just a standard form is giving, like IP access list, then it's a standard ACL extended. Their name can be, you can put the name, then you can, after entering that, you will be going in this specific mode. Then you can permit or deny to anything from a specific source, put the wildcard or anything else, and you can call that access list in the IP access group name. It's for inside, like incoming or outgoing, depend on your traffic or your solution. And okay, so it's just example how you can modify an access list. Let's say you put this access list is the standard one, you are denying a specific host, and this is the host. And you're creating one more access list, and you're denying rest of the traffic. Let's say 192.168.0.0, so it can be 192.168, and rest of the third and octet is allowed. So how you can do that if you want to change this specific host? So it's a kind of override thing. So you can basically retype access list one again, deny statement again, then you can put the host again and just type the new IP 10.22. So when we do, this one is the earlier one and this one is the new one. So after putting this in the going to the configuration mode, you have to remove the IP first or the access list. Let's suppose, let me give you access list 1 and you type 192.x.x.x, then wildcard something, and you want to override this. So you have to go into the configuration mode, then you have to type no access list 1, it will be removed. After that, you can use the exact same command. So it will overwrite it like the access list 1 host 192.168.10.99. Yeah, so it will be overwrite. After that, you have to put the permit statement and whatever the statement is. So that's how you can, like, you have to remove the old one and you can add the new one. That's how you can overwrite it. Okay, so the next one is the same thing. Like you create the access list, then you create a permit statement. Like the first one is the deny, second one is the permit, and this is the show statement. Once you type show IP access list, it will show, okay, like the first one is the deny statement, the second one is a permit statement, and with a specific wildcard mask. Let's say you go to the configuration mode, you just go inside, like although both of them are in a single access list, so you just type IP access list standard and you type 1. So once you enter that, you will be inside this specific standard access list. Means you will be inside access list 1. Whatever configuration you will be doing, that will be depending, okay, you want to remove specific thing or not. So when you do the show, it will be showing, okay, the first statement is 10 deny something, second statement is 20 permit. It's a sequence number, that's it, nothing else. It's a 10 is a sequence number, 20 is a sequence number. It's a random number you can put if you want to put in a manual way, you can do that. So you go inside the standard one, you just want to remove the first statement. What's the first statement? 192.168.10.99. That's denying a specific host. You want to remove the statement. So no, 10, and it will be removed. But you want to change it now and change it to a new IP. That's the 10.10. So you just have to type because you already inside the access list. So you just type 10, deny, what is the host? This is the new host, and that's it. You can go and you can write your configuration. Once you do the show access list again, the new host will be showing here. So this thing will be used like instead of removing the whole IP, like whole access list one. If you remember, we have done in the previous slide, no access list one. For that, we have to recreate this one with a new host, and we have to copy paste the exact same again. So instead of doing that, you can just type go inside the access list one here and type the specific sequence you want to remove, either it's a deny one or a permit one, depend on the you. Okay, this is some output that is given when you do the show access list. This is the access list. Then you create a IP access list again and specific access list having a different, like this is the same one earlier. You just put one more statement, like there are 10 if you remember. There's a 20, you just create one more. You just type 515 deny, there's one more to be denied, and when you do the show again, all three will be showing. In the previous slide, if you're seeing that, having the sequence number 10 and 20, you add one more 15, the 15 will be showing in the orange. Okay, this is some of the show command that you can. Okay, show IP interface 000, it will be showing if there is something in the outgoing, like any access list is there, or if you check, like it's for a different interface, for a different interface, then it will be showing you the access list if there is an access list for incoming or outgoing. That's it. And the show command, again, it will be showing you the all the access list. Show access list, it will showing, okay, you have created one access list having these two statements, then it's another one with the name no access having these three statements. So you can cross check all the access list present in the router by show access list only, or you can type show access list and a specific access list, or in some of the devices of the Cisco, it will be showing like that, show IP access list, and you do the question, or you can put your access list name. So that's how the command will work. Okay, next one, some of the show statement again, show access list again, 2 from access list 1, 3 from access list naming no access, then again output after pinging PC3 to PC1. Okay, it's just showing the output only. Here is the normal output. Let's suppose if you remember here, like we have put access list here and to block the PC1 can't reach to PC2 if there is any PC3 as well that I give the example. Let's say PC1 try to reach to the PC2. So it will be either it's a blocking or it's a allowing one. So you will be seeing, okay, 8 times it will be tries or it will be denied. So the total number of, you can say, the pinging or deny will be mentioned here, like 8. Earlier it was 4. Then you try the pinging again, then it's 8 here. The A 4 more packets has been added. That's it. Okay. It's a just access list. You create one access list, give it to the name, traffic use. Then inside that you create a sequence permitting something, this. It will be anything. It will be like that in actual scenario. Although it's a show statement, so you can create like this access list, traffic use 10, sequence 10, permit, then the same thing you can copy paste TCP any coming from the port 80, 20. These are extended ACLs here. And don't get confused with this number. This is the sequence number, not the access list number. This is the sequence number only. This should vary, like you can't use the same number else it will be a contradiction. Okay, extended list, we already discussed that. You can use that used to filter the source or destination or protocol or the port number or all four at once. Depend on you. Just take another example how we can do the filtering with the help of the port numbers. So again, we already discussed that access list. This is the access list number one. It should be 100, more than 100. That's how the extended access list numbering starts. Then you want to permit something. It's a TCP protocol. This is the host IP. This is the wildcard showing that first 3 octets should be allowed, fourth can vary, and it will be allowing anything coming from a port number 23. Then next statement 21, then 20. Okay, it's the same statement. And instead of this number, you can mention the services as well. Like for Telnet, port number 23 is used. If you know, if you heard about this, it's a standard thing. For FTP, we normally use port 21. For FTP data, we use port 20. So instead of mentioning the port number, you can mention the service as well. Depend on the you, how you want to create your standard access list. Sorry, extended access list. Okay, so applying standard extended access list to the interface. It's the same thing. Let's suppose this is a router, and you can't apply that to the switch. Okay, that's why we are using for the router only. Let's suppose we create one extended access list 103, which is permitting from the host 192.168.10.0. So 10.0 this host, and fourth octet can vary, and whatever is coming, it will be coming with from the port number 80. You can say that, or you can want any service. Then we have another access list 103 same, permitting something for the same host with a different port number or service. Then third one is a different access list permitting everything with the same host and having a wildcard which will be showing that fourth octet can vary. Then you have to establish everything. And we are putting that on gig 0 by 0 on this specific interface. So for 103, first two access list we are using for incoming. Mind my writing, please. So if S1 is sending something, like if something is like the LAN should be connected in lower. If a LAN is sending something and it will be landing on the switch will be passing it to the router one. So if on gig 0 by 0, we are using the first two access list, this first two access list 103, and what it's saying that we have to allow if something is coming from host 192.168.10.0/24, this host, and with two port number 80 and 443. So we'll be allowing that, and access list 105, this is for outgoing traffic. If R1 is sending something downwards, let's say there is a LAN downward, so it will be permitting whatever is coming for the source 10.0.0 and it will be sending that. This is basically a standard and extended list for incoming and outgoing traffic. That's it. Okay, creating named access list. What is the name access list? Okay, extended ACL. If you remember, we created access list earlier. If you remember in this slide, I mentioned that. Yeah, this one. You create access list, traffic use. In the same way, you can create. Just go to the IP access list, create name, permit anything, any host, any wildcard, any service with a port number depend on you. In the same way, create another one, call that inside on the interface, access group incoming and outgoing. You can put that. You just have to give a naming convention. Let's say the name is IP access list ABC. Inside that, you can mention you want to permit something. This is a source. This is the wildcard. Any service equivalent to port number 18 or equivalent to port number 443, depend on you again. Then you create one more extended list, IP access list extended ABC. Then again, same statement. You can put any statement or different statement. You can call them for incoming and outgoing traffic. And when you do the show IP access list with a specific naming, let's say you type show IP access list ABC. The traffic should be the output should be something like that, and it will be showing the output like this. Of course, that depends how many sequence you are defined. Sorry. Okay. If you remember, we talk about like we are using the IPv4 access list right now, and there's IPv6 access list as well. But in the current networking scenarios, IPv6 is coming to the picture right now because all the IPv4 IPs are consuming now. So if you know like how to use the IPv4 address or IPv6 address, I'm not going to tell the difference here. I'm just going to tell you standard difference here. That's it. What's the difference? So in IPv4, we heard about standard, extended. Standard can be numbered or in a naming way. Extended can be numbered and naming way both. But when IPv6 is coming to the picture, it can be only in a naming way. Like you have to mention the name. You can't mention the number. Like if you remember IP access list, we remember like that 192.168.10.0.000.255. It's a standard sorry access list. In a standard ACL, you can in case of IPv4, you have mentioned any number here, okay? But when IPv6 you're using that with IPv6 you can't mention. You have to type a name. Only name will work, and it has a functionality of extended ACL only. Like this is the standard one, and when you type access list 103 192, it's the extended one I'm sorry creating here. Okay, so IPv6, sorry for that. IPv6 will be using the same functionality as the extended one, but it can be named only. Move to the next slide. Okay, just a comparison. Where similar was the other comparison. Traffic filter command to perform is a separate command instead of permit or deny. Excuse me, I'm just sorry for the interruption. I have just kind of a bit of cold. Okay, so you can use traffic filter in case of IPv6. There will be no wildcard because the statement should be like this. I'm not going to explain. I'm just giving a general view here. So the statement will be coming to the when you do the show IP access list, it will be coming. Let's say IP access list. Let's say ABC. I'm just giving it. So the rest of the stuff will be coming like that. Permitting ICMP coming from any source and any destination, and this. These are the kind of default statement you can add. Okay, so it's some example how you can put the access list. Again, just the basic one. If you're familiar with the IPv6 architecture or IP, how you define the IP. So this is the IP of PC1, PC2, 3, and this is the specific subnets. interface, and this is their IP, specific interface IP here. So we on interface S00, let's go to the R1, sorry, S000. Okay, this interface. On this interface, we are putting a IPv6, we are doing a filtering, no R3 LAN access in. So R3 won't be having any access to the LAN. So we have create one access list which won't be allow any LAN access on this specific incoming interface. So what it will be doing that whatever is coming from R3, let's say if PC3 want to use PC2 or PC1, they count if we put this access list, specific access list. Inside that will be defining that okay, this specific subnet is blocked or this subnet is blocked or this specific subnet is blocked. So depend on you. So if something is from PC3, they want to use PC2, PC1, they can't use the LAN on this side on S1 or S2. Although it's coming from this point only, so that's why we directly put it here instead of here and here two ways. Okay, so there's one more access list. It's not the access list, it's a path list that will be working same as access list. So how the path list will be working? Let me give you example. Mm, let's say this is a R1 router having AS1. This is R2 router having AS2. This is R3 router having AS3. This is R4 router having AS4. And there is, let's say, this is a firewall having AS10. And this is SD-WAN having SD-WAN VH device, let's say, having AS20. Let's suppose we want that, and there's another one, R6, having AS6. Okay, so we want that everything is allowed. Let's suppose that everything is allowed from here to here, everything is allowed from here to on R6 side. So we want that if some SD-WAN traffic is coming, we want that when the specific traffic landing on R4, it's the eBGP's neighborship is working between all of them from R1 to R2, 3, 4, 5, 6, SD-WAN firewall, sorry, normal firewall and SD-WAN VH. There is a eBGP neighborship. So why we use the AS path list? So let's suppose if everything is working fine, we are allowing everything. So SD-WAN routes will be going to the firewall. Firewall will be sending them to the R4. R4 will be sending them to the R3. R3 to the R2. R2 to the R1. And same when it lands on the R4, R4 will be sending to the R6 as well. So what we want that when this VH router is sending something, so we don't want this to go from R3 to the R2, but it's okay to send to the R6. We want that. So how we can do that? Or we want that between from R3 to R2, only the SD-WAN route will pass. If R6 is sending something or firewall is sending any specific route that they receive from any XYZ source, let's say R10, R11, having S number 10 and 11. If they receive something from other side, that won't be passing. From R3 to R2, only the SD-WAN routes will be passing. So how we can achieve that? We can achieve that with the help of ACE path list. And somebody will be saying, okay, we can use a ACL here. Yes, we can. But let's suppose if we have 10,000 routes, you can't use and having a different ACE numbers. Sorry, not the ACE number, different subnet. Let's say one subnet is 10.1.1 20, sorry, 0/27. Another one is 10.1 22 0/21. Another one is 21 20 0/16. So it depends. So you can't create a summary for 10,000 routes. So instead of that, although you can, but it's not very easy to put so much routes on R3 or R2. So you can that you what you can that you can create a AS path list. AS path list can be used to allow any specific AS or deny any specific AS. So how we can use that? It's the same scenario like in the access list, like when you define the access list, IP access, list one permit any host and their wildcard mask. So in the same way, you just type IP, AS path, access list, then you type any random number. It can be 1, 10, 20, 30, depend on you. Okay, you want to permit. Let's suppose 3257. Let's suppose instead of 20, this is 3257. This is the AS number of SD-WAN routes. Let's suppose, for example. So we have created one AS path access list which is permitting only 3257. We create a route map. It can be anything. This is just the name which is permitting. We just enter one statement and match that access list. And when we are creating the BGP, this is the BGP configuration of the this neighbor between R3 and R2. Let's suppose this is R3. So let me give you a separate example. Give me 1 second. Okay, here as well, let's creating will be creating our own BGP configuration. R1, R2, R3, R4, firewall, SD-WAN, 3257, AS3, AS2. Let's suppose we are on R3, we defined router BGP3, neighbor, this is 2222, this is 3333. So neighbor 2222, remote AS2, neighbor 2222, route map ABC. So what's route map ABC? Inside the route map ABC, this is the route map ABC permit 10 IP AS. My bad. You directly type match AS path list 1 and you already created the AS path list. This is the AS path list which is permitting specific coming from 3257. This is the 3257. So what it will do, let's suppose there are other as well. So everyone will be sending the traffic from here to here. They will be sending, this will be sending. So when all the traffic landing on the R3, R3 will be checking over on my outgoing interface to the R2. We are creating one ACE path list that will be allowing only the specific traffic coming from the ACE number 3257. So they'll be checking their BGP route table, show IP BGP. They'll be saying, okay, we will be having a load of routes, having a load of number that's coming from the different ACE number. Let's suppose we have one route 1111 coming from 5 ACE number, let's say 3257 1 2 3 4 3257. Then another one 2222. They will be coming with is number 10 22 11 3257. Then there is another one 3333. They'll be coming 11 22 30 40. So here on R3 specific point, it will be checking, okay, I have one route 111. Is 3257 coming to the ACE number? Yes, it is. It will get it passed. Then it will be checking, okay, I have one more route 2222. Is it having the ACE number 3257? Okay, it will let it pass. Then I'm having one more AS path list having 3333. Is it having 3257? It won't. So it will deny that. So that instead of putting 10,000 access list, let's suppose if we have 10,000 route here, SD-WAN is sending. So instead of using 10,000 access list, extended list, or prefix list, you can create one IP AS path access list and just deny or allow the specific traffic. So and make it happen easily. And one more thing, when you type when you're creating an access list like that, let me go to the this slide. Yeah, here IP access path. Let's suppose let me create it here. Okay, IP AS path access list one permit 3257. So these two things, it will be showing that okay, it will be allowing if something is that is not coming from a direct AS number. Let's suppose if you are using the same access list, but in the end you are using this, it's a dollar sign in that. So it will be showing that okay, if this AS is is coming from the directly connected one, like let's suppose if a route is coming, we have already talked about the first statement. Let's suppose we use this statement. This is the second statement we put, and first one is not in the picture. And if you put this statement, let's suppose if a route is coming with the AS number 1, 2, 3, 3257, then 2, 2, 2, 2, 10, 11, 3, 2, 5, 7, 41. Then there is a third statement, 3, 2, 5, 7, 22, 31. So although there is 3257 in the first route, second route, and the third route, but if you use this second statement only, not the first one, so what it will be doing, if it's coming, if the next AS number is 3257, only that it will be allowing the specific route. Next AS number means 111 is having receiving something that is passing with the AS number 327, but the next AS is 1, so it will deny the statement. 222, next AS is 10, so it will deny this one. 333, next AS, the immediate AS is 3257, so it will permit only 33333. So you have to vary, you have to keep that in the mind if you want to allow a indirect AS number or direct AS number. That's depend on you. That's how you can create your statement. And this is just a if you want to filter on the basis of AS number, you can use this command should be BGP reg XP and then type this AS number. It will be showing everything coming with the AS number 3257. Or there's a normal statement you can do like you can type show IP BGP or you can use the pipe include 3257. This will work as well. Okay, so this is end of the tutorial. So thank you so much. I hope you learned something new today. And this is my channel at the rate arc underscore tutorials. I hope you will subscribe this one and we'll be coming with more videos. Please do let me know if you have any specific topic you want to learn. So thank you so much, guys. Thank you.